For today, we're going to be looking at questions 23 through 32. Every Thursday, I like to make a review of the week. So let's review. Let's see what we saw this week. We have a quiz this Friday, so make sure that we know what to do. So we started by completing a congruent statement, right? Congruent statement means things are equal. Two things, either two sides are equal, two angles are equal. I can even say two chairs are congruent, right? They're the same shape, same size. So complete each congruent statement by naming the corresponding angle or side. We said that when we talk about sides, I need to use two letters. When I talk about angles, I can either use one or three letters. Okay, so let's take a look. Here, this says angle B is congruent to, I look at B is the first letter on the left side. On my first triangle is the first letter. So I could even look on the other side, the first letter is letter G. So I could say angle B is congruent to angle G, right? For angles, I can choose one letter. I could also say angle DGI, or I could even call it angle IGD. All these three possible choices are the three possible answers. Either one of these three is correct. When it comes to angles, we can use one letter or three letters. Make sure that when you use the three letters, the vertex is in the center. So notice how I kept letter G in the center. DGI or IGD, right? But G is in the center. Then we moved into segment addition postulate. The main idea of segment addition postulate says that we can have one segment, let's say that's one segment, added to another segment, and this makes a big segment. That's the main idea from the segment addition postulate. Another thing that we have from here is, let's say I have a segment, and let's say I have another segment. Combine, make a big segment. The only thing though is that in this case, there's an overlap. So I'm gonna add the two small segments and I'm gonna subtract the overlap. Because notice that by adding the two segments, the two small segments, I am making the big segment, but I'm using the overlap twice. If they don't overlap, I don't have to subtract it. But if they do, I do have to subtract the overlap. So let's take a look at what I mean with this. Let me erase this real quick. I notice I can have this segment, right? It's a small segment, and I can add it to this other segment. And combine is going to make a big segment. There is an overlap, so I have to subtract the overlap. Let me solve for x first. The way I'm going to do this, let me add the two small segments. So I'm going to go 20, that's the first small segment, plus x plus 1, right? There's the other segment, and I'm going to subtract the overlap. The overlap, let me put it inside parentheses. I notice the overlap. Let me do this segment. Let me cut this right here. This is the overlap. I notice on the very, very top that the overlap is 2x minus 12. And all of this is going to equal to 13 plus x. Notice I added two small segments. Let me emphasize, this was one segment. This was the other segment. And I subtracted the overlap, and that was equal to the big segment. Now let's get rid of parentheses. The first thing that I do when I'm solving for x is get rid of parentheses. So I'm just going to write 20 plus x plus 1. Now here for the parentheses, let me distribute the negative sign. So it's going to give me minus 2x plus 12. It's equal to 13 plus x. The first thing I did is get rid of parentheses. Let me separate my sides through the equal sign. Next thing I'm gonna do, let me combine my like terms. On the left side, I see 1x minus 2x. So that gives me a negative 1x. I also see 20 plus 1 plus 12. Right, so those terms that don't have the letters, 20 plus 1 plus 12. And that is 33. So the left side simplified to negative x plus 33. On the right side, there's nothing I can combine. So let me leave that as 13 plus x. I still want to combine like terms. I notice I have x's on both sides. I'm going to move one of them. Personally, I like to move the smallest one in order to avoid negatives if possible. So let me move the negative x. This negative x, let me move it as a positive x. When I move something from one side to the other, I gotta switch the sign. This 13, let me move it to the left as a minus 13. I move letters to one side and numbers that don't have a letter to the other side. When I look at the left side, 33 minus 13, that's 20. On the right side, 1x plus 1x, that's 2x. Let me divide both sides by 2, so I find out that x is equal to 10. I said I wanted to solve for x in order for me to continue. Don't think we're quite done, right? The question here is find the measurement FH. It doesn't say solve for x. FH. I notice from F to H is a distance x plus 1. I know what x is. So initially is x plus 1. But I know the value of x, so let me write this as 10 plus 1, which is better known as 11. Moving along, let's take a look at question number 25. Name the vertex and the sides of each angle. Vertex, I mentioned vertex looks like the first letter. If I make it a little bigger, it looks like a corner. Vertex is the corner of the angle. In this case, is the point G. Now the sides, keep in mind sides, plural. There's two sides. There's two rays that start at the vertex. One of them is going to be the ray GH. What I'm saying with that is a ray that starts at G and goes through H, and the other ray is the ray GF. Starts at G and goes through F. That's the vertex and the sides. The way you guys are going to see it in your homework, something like this. Name each angle in 4 ways. So we're going to look at this in 4 ways as well. So one way I can label this, the angle, I can just call it angle K. Well, I could also call it angle 4. That number there is the name. So I found 2 ways. The other 2 ways, because it's 4 total, the other 2 ways I'm going to use 3 letters. I'm going to use the 3 letters that I see there with K in the center. So I could call this angle LKJ, or I could call this angle JKL. Those are the 4 possible ways. On my work here, it says choose the wrong name for this angle. The one I don't see that is from the correct list is D. Here for D, it says angle KJL, but I was supposed to leave K in the center, not J. So that's the wrong one. Make sure in your homework, you're going to be asked for the vertex and the sides. You're going to be asked for this, but you're also going to be asked for the names of the angles. How do you name an angle? Make sure you know how to name it. Now, question number 27. Remember, I'm working up until 32. Question 27 is how to measure an angle. So I see a protractor there, and I see 2 segments. The vertex is centered. There's usually a circle there on the protractor. So that's where I see the vertex, right? The corner of the angle. My first segment, I see that if I use the numbers on the outside is 100. If I look at the number on the inside, it's 80. So I see there's a number on the outside and a number on the inside. On my other segment, the number on the outside is 150 and the number on the inside is 30. The way I'm going to find out what's the measurement of this angle, I'm going to subtract my numbers. Now I have a choice. I could use outside numbers only. And when I mean outside numbers, I said 150 and 100. I could use outside numbers only, or I could use inside numbers only, like 80 and 30. To be honest, I would rather deal with small numbers. So I'm going to subtract the inside numbers, 80 minus 30. And I'm going to do 80 minus 30. And that gives me 50. So that angle is 50 degrees. If you subtract the outside numbers, 150 minus 100, you get the same result. But outside numbers only or inside numbers only. Do not mix and match. Now let's take a look at question number 28. I have to classify each angle as acute, obtuse, right, or straight. The right angle, I know, looks like an L shape. That's a right angle. Now, an acute is less than that. It's less than 90. So imagine an L shape, just close it a little. So something like this. An obtuse angle is more than 90. So imagine 90 degrees. Imagine an L shape, open it a little bit more. So something like that. And the straight angle kind of says it all. Should look like a line. Right? It looks straight. Now looking at this figure, question number 28, that one seems to be acute. It looks less than 90, more than 0, less than 90, so that makes it acute. I don't need to measure it to find out exactly how big it is, as long as it's between 0 and 90. I don't really care how big it is. Let's take a look at question number 29. For angle addition postulate, I'm going to add two small angles, and I'm going to make a big angle. One of my small angles, it's going to be this one. We can say that's the angle JKY. Something about JKY. It's right there. I know the first angle is 64. The angle JKY is 64. Another angle that I see, another small angle is this one, YKL or LKY. For that information, I know the measurement of YKL is 6x minus 6. So let me add those two small angles. I'm just going to write 64 plus 6x minus 6 equals, right? I'm adding the two small angles. Then the big angle, it's there, right? I painted in yellow is the JKL angle. And I know the measurement of JKL is 10x plus 14. So I'm going to let this equal to 10x plus 14. All right, I have an equation. So equation is something where there's an equal sign. I can solve for x. Let me separate them through the equal sign. First of all, I see if there's any parentheses. If there's any, get rid of them. There's none. So let me combine like terms. On the left side, when it comes to letters, I only see 6x. That's the only letter that the only term that has a letter. Now numbers, I see 64 minus 6. I know that's 58. On the right side, nothing can be combined. So I'm just going to call this 10x plus 14. The 10 has an x and the 14 does not. So that's why they cannot be combined. I still want to combine like terms. I want to have the letters together. So the 6x, let me move it to the other side as a minus 6x. Got to switch the sign. The positive 14th, let me move it to the other side as a minus 14th. Got to switch the sign. I know 58 minus 14 is 44. So I have 44. It's equal to 10x minus 6x is 4x. So I have the 44 is equal to 4x. To have the x by itself, let me divide both sides by the number in front of it. So in this case, let me divide both sides by 4. So I get that 11 is equal to x. I know the value of x, but I go back on my instructions. In the beginning of my instructions said, find the measurement of angle JKL. JKL is the big angle. I know JKL is 10x plus 14. So for right now, let me write this as 10x plus 14. But then I know the value of x is 11. So let me write this as 10 times 11 plus 14. I know 10 times 11 is 110 plus 14 is 124. So my result in this case is 124. Let's do another example. Let's take a look at question number 30. One of my small angles, I see this one right here. I'm using the letters G, H, and J. Leave H in the center. So let's see, G, H, and J. All right, leave H in the center. So GHJ or JHG, I know that's 84 degrees. The other small angle, it's this one. Using the letters J, H, and I. Leave H in the center. I know that's 7x plus 16. Let me add those two small angles. So I'm just going to go 84 plus 7x plus 17 equals, now the big angle, GHI, or IHG, right? As long as I'm using the same three letters with H in the center, I'm going to say the big angle here is 19x minus 7. So I added two small angles and equals the big angle. Let me solve for x. On the left side, let me combine my like terms. When it comes to letters, just 7x. When it comes to terms that don't have a letter, 84 plus 17, I know that's 101, equals 19x minus 7. Those cannot be combined. One of them has a letter, the other one does not. Now, trying to combine like terms, I see the x's. So let me move the smallest x. The 7x, let me move it to the other side as a minus 7x. And then this negative 7, let me move it to this other side as a plus 7. Anything that I move to the other side, I switch the side. I know 101 plus 7 is 108. 19x minus 7x, 19 minus 7 is 12. Let me divide both sides by 12. Now 108 divided by 12 is 9. 9 is equal to x. But I go back to my question here. Find the measurement of angle IHG. And I know IHG is 19x minus 7. So let me do this again. 19x minus 7. I know the value of x is 9. So let me rewrite this as 19 times 9 minus 7. I know 19 times 9 is 171. Minus 7 gives me 164. All right, two more questions. Let's take a look at question number 31. I see there's one small angle, and then there's another small angle. Interesting part. So let me add those two angles first. X minus 7 plus 2x plus 1 equals. Now the big angle happens to be 90 degrees, right? That little box represents 90. So I'm going to say those two angles combined is equal to 90. Let me solve for x. On the left side, let me combine my like terms. 1x plus 2x is 3x. Negative 7 plus 1 is negative 6. And all this is equal to 90. I want the x by itself, so the minus 6, let me move it to the other side as a plus 6. So that gives me that 3x is equal to 96. Let me divide both sides by 3, right? The number in front of the x. 96 divided by 3 gives me 32. Then I go back to the instructions. Find the value of x. Oh, cool. I already found x equals 32. You only have to type in the number. Notice I added two small angles and equals the big angle. Now in question number 32, I'm going to add 31 degrees. So I'm going to add this angle, 31, plus this other angle, which is x minus 121, plus this big angle, which is 2x, equals, okay, now I notice that combined make a circle. The circle is 360 degrees. So I'm going to let this equal to 360. Let me separate my sides to the equal sign. When it comes to letters, I have 1x plus 2x. That's 3x. When it comes to numbers without a letter, I see 31 minus 121. 31 minus 121 is equal to negative 90. And this is equal to 360. To have the 3x by itself, the minus 90, let me move it to the other side as a plus 90. So I have that 3x is equal to 450. Let me divide both sides by 3. X is equal to 150. The instructions were solve for x. So there you go, 150. Let me zoom out. That way you guys can take a picture or work. That's it. That's what we work on today.